Hello everyone, my name is Pooja Maindarkar. In modern automotive electronic system, my topic for presentation is temperature sensor. Let's have a look at the content. Introduction, sensor types, automotive temperature sensor, thermistor, engine coolant temperature sensor, intake air temperature sensor, exhaust recirculation gas temperature sensor, and application. Sensors are widely used in many different applications, and sensor technology has become a basic enabling technology in many instances. The rapid increase in the interest in sensors have been driven by numerous systems such as physical, electronics, chemical, mechanical, and biological systems. Temperature is most often measured quantity after time. Temperature, the measurement of temperature is most commonly used in food processing, environmental control, medical devices, and in automotive. It is also used to ensure that the process is staying with certain range. Generally, temperature sensors fall into two distinct categories, defined as contact and non-contact. It must be remembered that sensor, and particularly those that measures temperature inherently have problems with accuracy. Many readings should be made in order for the final results to have decent level of accuracy. Contact temperature sensors essentially measure their own temperature at any given time. They do this by creating a thermal equilibrium between the sensor and the substance being measured. Thermal equilibrium simply means that the two bodies having no heat flowing between them and are hence the same temperature. There are, however, a variety of errors that can occur while using this type of sensors. For instance, surfaces are especially hard to measure with contact sensors. Contact sensors are by far the norm for temperature measurement in science and industry. Types of contact sensors include thermocouples, resistant temperature detectors, thermistor, field system thermometers, and bimetallic thermometers. In non-contact sensors, an infrared sensor is used to measure the temperature of an object by reading the level of the infrared emission. Some of the non-contact type of temperature sensors are pyrometer and infrared temperature sensor. Automotive temperature sensors are used to measure temperature at many places in automobile and usually consist of either a thermistor, which is thermally sensitive resistor, thermocouples, resistant temperature detectors, or infrared devices. Thermocouples are usually used for higher temperature measurement, such as exhaust gas temperatures, and infrared sensors are used when the direct contact with the object being sensed is undesirable. RTD, which is resistant temperature detectors, rely on certain metals, usually platinum, nickel, or copper. Thermoresistive behavior to detect change in temperature. RTDs respond to temperature changes very linearly and can achieve good accuracy. Thermocouples, which is a type of temperature sensors, operate on a principle that a voltage that changes with temperature can be produced by a junction of two dissimilar metals joined together. Thermocouples can be used when very fast response times are needed. Now let's have a look at thermistors. Thermistor sensors is a sensor that can detect liquid or air temperature and gives output as an electric resistance. If thermistors are exposed to external heat, the resistance drops drastically and the supply voltage remains constant. Their input current climbs rapidly. This property is utilized for temperature measurement. Thermistors are made from a semiconductor material whose resistance varies with temperature. Thermistors have two variations: positive temperature coefficient and negative temperature coefficient. This type refers to the direction of resistance change with respect to an increase in the temperature. For instance, a positive temperature coefficient type resistance will increase with rise in temperature, and negative temperature coefficient type will behave in the opposite manner. Thermistors generally have lower temperature limits than a thermocouples or an RTD, but they are less prone to signal interference. The temperature sensors which are used in automotive measures air and liquid temperature between the range of -40 degrees Celsius to +130 degrees Celsius. For proper amount of fuel injection, commonly used automotive temperature sensors are coolant temperature sensor, intake air temperature sensor, and exhaust recirculation gas temperature sensor. This is the diagram or the picture of the three sensors, and the blue color, the round blue color which can be found in three of the sensors is nothing but the thermistor. Let's have a look at the first temperature sensor, that is engine coolant temperature sensor. A coolant temperature sensor, also known as ETC, that is engine coolant temperature, is used to measure the temperature of the coolant or antifreeze mix in the cooling system. A coolant temperature sensor is confined to the engine of a vehicle and measures the temperature of the vehicle's engine coolant. The sensor feeds this information back in the form of an electrical current to the engine control unit. The engine control unit then responds to a change in the temperature difference and readjusts the engine's fuel injection. Critically to many ECM functions such as fuel injection, ignition timing, variable values timing, transmission shifting, etc. The vehicles which are computer equipped often uses the engine coolant temperature sensor. When the engine is cold, the fuel mixture must be reached to prevent the stalling and the engine stumble. The ECT sensor is used as an input for the following. That is, the output of the engine coolant temperature sensor is used as the input for ideal air control position, oxygen sensor which is in a closed loop, and for ideal speed. A basic functional principle to a coolant temperature sensor begins with the ignition switch. When an ignition switch is on, a voltage passes through the resistor and heats it up. The resistor is connected to an electrical grid that behaves like a data logger, measuring the temperature differences of the resistor. In the event of air traveling through a vehicle engine, which can come as a result of heavy acceleration, the resistor to the sensor starts to cool down and drops its resistor charge. To control and maintain a balance in the engine temperature, the coolant sensor detects the drop in electrical resistance and emits a voltage to the resistor, a process that is completed in the specs of milliseconds. It is important to monitor engine temperature as this will determine exactly how much fuel is to be injected into the engine. The engine control and monitoring unit assist in controlling the temperature of the engine by supplying 5 volts to the circuitry connected to the coolant temperature sensor, which allows for a measurement of change in the voltage drop between the resistor and the coolant temperature sensor. In car with an internal combustion engine, the cooling system maintains the optimal temperature of the engine and prevents it from overheating, as it has a negative temperature coefficient. In the picture you can see the coolant sensor. The intake air temperature sensor can be located in one of the following locations: in the air cleaner housing, in the air duct between the air filter and the throttle body. The working of the air temperature sensor is similar to the coolant sensors that we have seen previously. Next is EGR temperature sensor. The EGR temperature sensor is an engine management sensor that is a part of EGR system. The sensor is installed between the exhaust and the intake manifold. The EGR temperature sensor is an engine management sensor that is a part of EGR system. It works together with the EGR solenoid to control the flow of EGR system. The sensor is installed in between the exhaust and the intake manifold and monitors the temperature of the exhaust gases. When the temperature rises, the EGR temperature sensor will send a signal to the computer that will increase the flow in order to reduce the pressure and the temperature. Now let's have a look at the EGR temperature sensor working. As the temperature increases, the voltage signal decreases. The decrease in the voltage signal is caused by the decrease in resistance. The change in the resistance causes the voltage signal to drop. When the sensor is cold, the resistance of the sensor is high and the voltage signal is high. As the sensor warms up, the resistance drops and the voltage signal decreases. From the voltage signal, the ECM can determine the temperature of the coolant, intake air and exhaust gas temperature. So with this, we complete the working of EGR temperature sensor. Now let's have a look at some of the applications of temperature sensor in automotive domain. In this presentation, we have primarily seen the thermistor and how, based on the thermistor, the three main sensors, temperature sensor, work in automotive. Now let's have a look at some of the other temperature sensors. The first is the engine oil temperature sensor. This sensor is used to calculate the temperature of the engine oil. The measuring range of the engine oil temperature sensor is generally from -40 degrees to +170 degrees Celsius. The next is exhaust gas temperature sensor. The exhaust gas temperature sensor usually employ a platinum measuring resistor. Information from this sensor is used to regulate the exhaust gas recirculation system in an engine. This sensor is mounted in the exhaust system of the engine. The measuring range is usually from -40 degrees to +1000 degrees Celsius. Next is fuel temperature sensor. Fuel temperature sensors are located along the fuel delivery system and provide feedback to the PCM as to the state of the fuel system. Temperature ranges of this sensor is between -40 to +160 degrees Celsius. Next is the transmission fluid temperature sensor. This sensor is located on the body of the automatic transmission and is used to measure the temperature of the transmission fluid. The measuring range of this sensor is approximately -40 to +120 degrees. Next is tire and brake disc temperature sensor. These sensors are usually located in an area around the tire envelope, where the sensor can view the radiation emitted by either the tire or the brake disc. Since direct contact with these elements is not desirable, infrared temperature sensors are usually employed. Next is auxiliary heater temperature sensor. Some auxiliary systems such as sea heaters that may be installed, or certain vehicles will also have an associated temperature sensor to accompany them. These sensors provide feedback necessary to control these systems. Next is exterior temperature sensor. The exterior temperature sensor allows a person inside the vehicle to know the temperature outside of the vehicle. It is often located around the front bumper area. And the last is cabin temperature sensor. The cabin temperature sensor is usually found around or within the steering column. It measures the temperature within the vehicle, which will signal to the HVAC system to either increase or decrease the temperature to fit a desired range. So these were some of the applications of temperature sensors that are used in a vehicle in automotive domain. So with this, it's a completion of the presentation which was on temperature sensors. Thank you.